I would go to this video right here called Testing from Scratch Offline video. Would first watch that video, understand how unit testing happens, and then come over here and understand how integration and end-to-end testing happens. The goal for today is we do a quick recap of unit testing, the thing that we did last week, and then we move on to integration tests, understand what they are, write them for an Express application. Then we move to end-to-end tests and write them for a Next.js application. The call to action for today is, if you want, all of our repositories are mostly in Next.js other than the chess repository. So we have three big ones. There is chess, CMS, and daily code. Most of them are in Next.js. So you can bootstrap integration tests in both of them after today's class. And the third one is in Express plus Node.js. You can bootstrap either end-to-end tests or integration tests or even unit tests. Basically, none of our repos have tests, which leads to a lot of back and forth in merging, figuring out if something went wrong. So we want to improve coverage. After today's class, you have enough resources, knowledge to be able to introduce testing. If you don't want to introduce testing, wait for someone else to introduce it, and then write some tests yourself, try to improve coverage and go from there. Cool. This is the end repository for today. By the end of it, we'll try to understand two things: integration tests, end-to-end tests, and how to integrate them in your CI/CD workflow. So if you want, code along. If not, you can just find the code of everything we're doing here. With that context, it's 7:05, so I think we can get right into it. Let me quickly recap unit testing for the next 10 minutes or so. This is something we did last week. Let me share a little bit of the code snippets so you can get comfortable with unit testing if you haven't gone through last week's video. If you have, then this should be fairly straightforward. Recap of unit tests from last week. The following is a great example of unit tests. So this is the repository for last week 24 testing. This has some solid 5 modules that you can go through to slowly implement testing in both Jest and vtest. What is Jest? These are a few buzzwords that are good for you to know, if I'm being honest. There is Jest, there is vtest, there is it, there is describe, there is mocking. These are a few things that we learned last week. These are buzzwords you need to know even before you proceed. Let me quickly share what all of these mean. When you create an Express application, to begin with, give a high-level context of what testing is. When you create an Express application, for example, let's say you write code that looks like this. You have a /sum endpoint that users can hit. They can send 2 variables as inputs in the body, A and B. You do some quick validation on top of it. You make sure that the user hasn't sent very big numbers for some whatever reason you might have. We only support small numbers. You find the result. You put them in the database by using the Prisma client, and lastly, you return the result as well as the ID of this thing that you put in the database to the end user. This is one endpoint that we wrote last week. We also wrote the tests for it. If you write this endpoint, start the Express application, how would it work? You would go to localhost :3000/sum. You would send a post request. You would send 2 inputs A and B, and it would return you something like this. Okay, the answer is 3 because that's what it's calculating, and the ID is 2. That might be the ID that the database returned when this specific database call happened. That is how this endpoint currently would work in production. But how do you test it? You can either manually test it by doing something like this. I will send multiple inputs and try to see is the sum correct. Or you can write automated tests. That is what we did last week, which is we wrote a bunch of unit tests. What are unit tests? They basically help you test this unit of code while ignoring database calls. I repeat, what is a unit test? I don't care about the database. Database is too big a thing for me to start whenever I'm doing automated tests. So I will ignore this call. I want somehow this code to run and this code to run and this code to get sort of ignored. That is what unit testing means. You mock out all the external services. Database is one external service. Queues, RabbitMQ, PubSubs, Kafka, Redis. These are all external services that you want to mock out while you are doing unit tests. How did we do that last week? How did we write the tests? Given this endpoint, the test looks something like this. Number 1, we wrote this line of code to mock out the Prisma client. Now, why /db? Because that is where the Prisma client was stored. I'm not diving too deep into this because we've covered this last week. So if you don't understand this part, or the whole test over here, feel free to skip the class, come back to it after you've done unit testing. But to quickly recap, we mocked out the database, specifically the Prisma client. Why? Because we wanted this Prisma client.request.create call gets mocked out. It calls an empty function rather than trying to hit a database. And then we wrote a describe block. What were the buzzwords I shared? I said describe is a buzzword. What does describe mean? It means you're trying to write a bunch of tests that test a certain functionality. For example, you're saying that this specific describe is going to test all the sum functionality. I will write a bunch of test cases here that will test the sum function. Similarly, I could have another describe block that tests, let's say, a multiply HTTP call or a subtract HTTP call. So usually you have these top level describes which say, okay, I'm going to write all the test cases for some functionality, and then you have individual test cases. Okay, this is my first test case. That is what it means. Okay, it should return 3 when 1 plus 2. If you spell it out, it's almost like you're speaking in English. It should return 3 when 1 plus 2. The endpoint should return you back 3 when you give it the inputs 1 and 2. Until now, we were testing it via Postman. My Postman is dead for some reason. But if you remember from a few seconds ago, I clicked on a send button and was able to send a request via Postman. That is manual testing. This is automated testing. Let me screen share one more time for people who just joined. This is automated testing. KR, if you ignore these lines for now, for some time, this line of code sends out a request to /sum, sends two variables a and b as inputs, and tries to, again, ignore this line of code as well, and tries to validate, okay, did I get back 3 as the answer? Expect rest.body.answer to be 3. If we don't get back 3, the test fails. If we do get back 3, the test succeeds. Also check a bunch of things like what is the status code, what is the ID that's being returned. So this much code, basically these 2 lines of code and the last 3 lines of code, is a very basic test that tests your server. But since we have a database to mock out, we had to add all of these mock resolved value calls, spying calls, and 2 have been called with calls. Thankfully, we don't have to deal with any of this today. Today, we will not do any mocking. We will actually start a database while testing. And hence, if you don't understand mocking or spying, it is fine for today. You should understand though, okay, how were we able to send a request? What is this request object? Where does this come from? If you remember, this comes from the supertest library. If you look at the top, import request from supertest. So we use the supertest library to send a request to our HTTP server on a specific route with certain inputs, and then we expect, okay, the answer is the correct thing, the ID is the correct thing, so on and so forth. I wrote another test over here which sends a very big input 100000, and here we expect the message to be, sorry, we don't support big numbers, because if you remember in the application logic, if A is very big or B is very big, we early return. We never reach the database call, and hence we never have to mock out the database call in the second test. In the second test, since we're sending very big inputs, the control will reach here, these would get extracted, control would reach here, A is very big, this would get returned, and hence we early return. For the same reason, the tests, if you look at it, doesn't have any of this extra spying logic, mocking logic. It simply sends a request and expects the message to be right and the status code to be right. That is how you write a simple unit test. Again, we have covered this twice in 2 videos last week. Today we'll try to write integration tests. They look very similar to unit tests. It's almost the same thing we are doing. We'll try to test a very similar application that has things like this, but we will actually start a database. An integration test says, okay, I want every part of my system to be up locally, and then I want to actually hit the database, actually inspect the database, actually, put entries in the database. That is what an integration test means. There are upsides and downsides to using integration tests. So, you avoid them a lot of time. You only write unit tests. But number one, it's a good thing to know. Number two, if you really want to test your app, if you want to see how it interacts with the database, interacts with Kafka, then you have to write integration tests for your application. So what are integration tests? If you don't mock out database calls, if you're actually if a developer comes to a company and joins this company, let's say this is the repository of a very big company. They're a new employee there. When they clone the code and run npm run test locally, if the database also starts while the tests are running, the Kafka service also starts on their machine while the tests are running, and then all of these endpoints get called, that is an integration test. What is a unit test? If the developer comes to this team and doesn't have Docker, doesn't have Postgres on their machine, but is able to run the tests, that means all of these requests have been mocked out, because if they weren't, then of course this request would fail because the user doesn't have a database. Hence, how do you know if something is an integration test versus a unit test? If the database is mocked out, it's a unit test. If it is not mocked out, it's an integration test. Today we'll be learning about integration tests. Let me do a very quick poll. Should we continue? Do we understand the context / recap of last week's class? Are we good to go, guys? Alrighty. That's beautiful. Let's proceed to integration tests. While unit tests are great, they mock out a lot of external services. This is great for testing the functionality of a function in isolation. If the only thing you are testing is, here, was this branch ever reached? Did the control ever reach here? Or did it get skipped and it reached here? If you want to test just this functionality, mocking this out is great. But integration tests are used to test how all integrated components work together. What are integrated components? Databases. Might be another backend as well. There might be two backends that are communicating. You start both of them. You start a database, you start Kafka that makes them communicate. You start everything in your system is when it's called an integration test. This means you have to start all auxiliary services before running your tests, and you don't mock out any external service calls. So if mocking and spying was a little difficult last week, this is a great out for you. You can just write integration tests rather than writing unit tests. But are there downsides? Yes. There's a reason these are avoided for a long time. There's a reason tests are only avoided, because people want to move fast. A lot of companies don't write tests for a really long time. When the team becomes very big, it's a good idea to write tests, or your code base becomes very big. It's a good idea to write tests. People write unit tests. Why do they not write integration tests? Because number one, they are slower to execute. You have to first start database, then start the other thing, and then run the actual test. So it will be slower. Number two, it adds complexity. Here they probably removes complexity. Look at this. This is so much complex code you wrote for mocking out things. Over here you wrote mock resolved value. It though should reduce complexity. Yes, it will reduce the code complexity. It will increase the complexity of starting something locally. Some user, some developer of your team might be on a Windows machine. They might not be able to start Postgres. They might not be able to communicate with Postgres. So their npm run test will keep failing, and they'll be very sad. That happens from time to time. Okay, when you have integration tests, thankfully it's standardized now with Docker. As long as you have Docker, integration tests just work. But maybe someone doesn't have Docker. They don't even know. Okay, they need to start Docker to run integration tests. So they get complex. Versus simple tests will most probably, when someone runs npm install, npm run test, it will just work on their machine. Number three, local development setup is required for a developer. If there's a random developer with a basic laptop that comes without Postgres in it, without Redis in it, without Docker in it, they will most probably not be able to start the services, and hence their integration tests would fail, even though they haven't made any code change. Only because they weren't able to start Postgres, their integration tests would begin to fail. That is why you avoid them. They're also good for repositories though, like the ones we have, in which there are, what's the best way to say? It can get tests like these can get very flaky, and I guess that's not a great point, but basically all the repositories that we have are highly full stack. And when you have extremely full stack applications, you should write integration tests or end-to-end tests. You shouldn't rely too much on unit tests. That's, ignore this specific point. I don't know why I said that. Prerequisites for writing integration tests. Before we write an integration test, we should write the code that, number one, brings up all the external services. Number two, seeds some data in there, creates all the tables in the Postgres Postgres database, and brings down the service when the test suite succeeds or fails. Before you even execute any tests, you need to first start Postgres on that machine. You need to start Kafka or whatever external services you are using. Once they have started, you need to health check them also. You need to check, is Postgres up? Has Postgres started? It has. So basically, whenever a developer is running npm run test, it doesn't start the tests. It doesn't go inside the describe block. It first starts Postgres. Most of the times using Docker. It then checks Postgres health. Has Postgres might take 1 minute to start. So it needs to check, has it been started? Has it been started? Then it needs to migrate the database. This is a fresh database. It needs to run npx prisma migrate, if you remember, or create the tables in there. Let the freshly created Postgres table know that these are the tables for the application. It then needs to generate the Prisma client in case you're using Prisma. You need to generate the Prisma client so your final tests can actually, use them. And lastly, that should be it. Then you can actually, go into the describe block, go into the it block, and actually start to test the thing. So before we reach here, let's understand how can we do all of this. How can we start, let's say just Postgres right now. Let's just stick to one, and then migrate the database, generate the client, go from there. The answer is fairly straightforward. You would do this just how you would do this, thinking from first principles. Yeah, if I had to do this, how would I have done it? The answer is, you would have written a script that looks something like this. Now, this might feel very overwhelming to a lot of people, but let me first show where we are going, and then of course we'll slowly build up to it. What did I say? I said, okay, if you're writing integration tests, before you run the actual test, you need to do a lot of these things. How can you do it? Do you need a library? There are some libraries that let you do it as well. But usually, what would you do? You will create a script like this. First, let me start all the services. Then, let me check, is Postgres up? Has Postgres actually started on my machine? Then let me migrate my Prisma database. This command also generates the client, so you don't have to run it separately. And then I will actually run the test. npm run test would actually start the tests. So you have to write an ad hoc script that looks like this to be able to run integration tests, just how you would think from first principles. Now there are libraries that let you in Node.js itself, in your describe block itself, write things like start Postgres. They will also under the hood start it in Docker only. So you can use that as well. I'm not sure if they're in Node.js, but there are libraries like this in Rust. Most Rust code bases that I've worked with, I forgot the name of the library. I was thinking before the class. They use a library that starts Postgres or whatever services you want to use in Docker directly in your code. What do I mean by directly in your code? I mean directly over here. You can, over here, let's say in the it block, you can write docker.start Postgres, and it would, start Postgres. You can do that also. I'm sure there's a library that exists in Node.js that lets you do it. Or you write an ad hoc script that looks something like this. One second. Forgot which slide it was on. Oh, there you go. That looks like this. Starts all the services. Waits for Postgres. Now, what is this wait for it? We will come to eventually. But waits for Postgres to start, and then migrates the database, actually runs the tests and brings it down as well. Whenever the developer comes and runs npm run integration tests, you want to make sure you bring up Postgres. You want to make sure you bring it down as well. So, you do this, you start services, do your thing, and then bring them down. Let's try to code this for a simple application. Let's quickly write the code for a basic Express app. Let's write this script that I just showed, and then let's write some tests and finish integration tests without writing any mocking logic like we did for unit tests. Let's do this really quickly. The final code of all of this is present here on week 25 integ E2E tests. Let me paste it in chat. So you can directly look here. If you want to code along, you can code along as well. We'll slowly try to build up the project. Let's create an empty project and initialize package.json and TypeScript inside it. Let me open this on the right, this on the left. If you want to follow along, You can follow along from the slides as well. Even though this isn't too much code, so you can, just look at the final code as well. Week 25 live 2. There we go. Let me open it in Visual Studio Code. And here, let me create a new folder called 1-integ-tests, where we'll be writing all of our integration tests. Then I'll create another folder for the end-to-end tests. And inside this, what did we have to do? Initialize package.json as well as types tsconfig.json. Done this many times, so not going to repeat what this means. Then what is the other thing we always do? We update root dir over here to be ./src and out dir to be ./dist. Again, something we have done many times. Then we bring in all the external dependencies. Notice I'm not bringing jest yet. I'm not bringing a vtest yet. I'm just writing my basic application in Express. So what do I need? Express at types/express and Prisma, because that's the ORM that we're using. Once you've added these dependencies, what do you do next? You create your Prisma schema. You describe what your database would finally look like. How do you do that? You first run npx prisma init to initialize a schema.prisma file. And then here is where you describe what all tables would exist inside schema.prisma. What command did I run? npx prisma init. This is a very basic schema that I'm adding. Our application would be very similar to what we've been doing last week. So if you remember, what we're doing is we're creating an application where people can come and send a /sum request or /multiply request, things like these. So if you want to store all of these in the database, what would the schema look like? Okay, there would be a requests table which stores the first value that the user sent, the second value that the user sent, and the answer that was calculated for it. If it was of type add, then of course the answer would be a plus b. If it was of type multiply, then the answer would be a into b. What is type over here? It is the type of request the user sent. Did they send a request to /sum or did they send a request to /multiply? So we store all of this in our database. Specifically, the type is of type type with a capital T, which is an enum. What is an enum? An enum lets you create variants. If you want to enforce, okay, there are only two things allowed here, either add or mul, then you can create a enum compared to a string. Can this be a string as well? Keep this as a string if this feels a little overwhelming. But if not, this is hopefully straightforward. Okay, you create an enum and that is the type of this. This is how we generate the schema. What's the next step when you're creating a full stack application? You write your code. You ideally migrate the database, but we'll get to there eventually. Let's not migrate the database yet. Let's generate the client though. There is a difference between migration and generation. Migration means you are actually migrating your database. You are telling your database, create these tables. npx prisma generate just generates the Prisma client locally. It generates a library that you can use in your index.ts. That is what the next command is that we run. And then you don't need to create a db.ts now because we're not mocking anything. But if you want, feel free to, doesn't matter. We needed this in unit testing because db.ts was the file that we were mocking. If you remember a few slides ago, what did I show? At the top of the test, we wrote v.mock:/db. This db.ts file was the file that we were mocking. But since we are writing integration tests now, we don't have to create a separate file. We can keep this in index.ts, or if you want, create a db.ts file and put it there. Remember to create an src folder first, because in tsconfig.json, we changed the root dir to be src, and here write db.ts to begin with, where you store and export the Prisma client. And lastly, index.ts where you write your express code. I will recap this very quickly. I think I went a little too fast, but let's quickly see. What did I say? This is the final express code that we need to put over here. Take a quick breather over here. Quickly recap the steps that we did. I started with an empty Node.js library, empty folder, introduced a package.json and tsconfig.json. Inside tsconfig.json, I changed the outdir as well as the rootdir. Then I initialized Prisma by running npm npx prisma init. Now where did it go? There you go. Npx prisma init to initialize a schema.prisma file. Then I wrote the schema for my application. Then I generated the client by running npx prisma generate. Then I created two files. File number 1, db.ts, that exports a Prisma client, which is this variable right here. We don't need to create this. I can simply write these two lines of code in index.ts as well. What does index.ts do? It imports express from express, imports the Prisma client from ./db, which, as I said, I can simply, copy these and paste these here. There's no reason to separate it in db.ts. It uses express.json middleware to make sure the body can be parsed. And then it introduces a simple /sum endpoint, very similar to the one we saw earlier. This is how I've initialized a basic full stack application, not full stack, backend application. What is the one thing that is missing? I've added the endpoint. I'm not listening. I'm not done app.listen of 3000. I'm not listening on a port. The HTTP server won't start. If I don't write the last line of code and try to compile and run this, it will exit. Why? Because I'm not listening on a port. Why am I not listening on a port in index.ts? If you remember from last week, because whenever the tests start, I want the tests to use this app variable. If you remember the tests from the slides, at the very top of the tests, I was importing app from /index. I need this app variable to be finally in my tests, and hence this is exported from here. Whenever the tests import this, I don't want an HTTP server to start. The tests will start it themselves. And hence, you make sure index.ts is not listening on a port. You create a separate file, usually called bin.ts. Bin stands for binary. For no reason. This won't create a binary. You simply run the JavaScript code when you're using JavaScript, but just standard convention. To create bin.ts, import app from ./index, or you can just write dot as well. And then app.listen 3000. We move the listening logic to bin.ts. KR, you will start when this user actually wants to start an HTTP server. You will just, index.ts will just store the app variable that will be used by both the things. This will be used by tests as well. This will be used by bin.ts as well. Now if I try to run it, if I run tsc-b followed by node dist/index.js, bin.js, you will see it's listening on port 3000. It did not exit over here. If I go to Postman and send a request, it fails because the database isn't up yet, and hence, Prisma throws an error. Please make sure your database server is running. But at least we know, okay, the control is reaching here in index.ts, and it is of course reaching this point at which it fails, which is fine. We don't have a database yet. But do we understand bootstrapping a simple Node.js application? Were you guys, the people who tried, able to do it locally? Shall we proceed to starting a database and then writing the tests for it, or more specifically the integration tests? Great. So you understand this. So we will proceed to now starting the database. Let's first make sure our application is running. For doing that, we need to start a database. How have we done it until now? We either went to Neon Tech, Avian, and got a free database for us, or we started it locally using Docker. Kirat, why did we not start it using Postgres? You can start it however you want. But this is the most easiest way to start Postgres. And that also makes it most convenient for writing integration tests. Whenever you're writing integration tests, you want it to run for everyone's machine, be it Ubuntu, Windows, whatever. And hence, starting using Docker is a better idea than starting using native PSQL or Postgres. So let's try to start this. This is the command for it. If you remember, we've done this in a class called Actionable Docker. This is how you can start Postgres locally using Docker. It will start it inside a container. What does the command look like? Docker run -p port mapping. Okay, 5432 of my machine should point to 5432 of the container. Environment variable, a password that I want to give. Run it in detached mode. Run it in the background. And the image that you want to run. I want to run Postgres, I put Postgres here. If I wanted to Redis, I would have put Redis over here. It gives me an error because I'm already running this. So let me kill my old container and restart. And you will see Postgres is now running. Where is it running? It is running on port 5432 of my machine. What is the password for it? It is this. What is the username for it? By default, the username is Postgres. What is the database called? It's called Postgres by default. You can change that, but we're just using defaults other than the password. Given that we have this, what do we have to do next in the database? I need to put the tables inside. I had created the schema. I had written this. I had not migrated my database. I had not put tables over there. How do you do that? Number one, you have the top level .env file that whenever you initialize Prisma, it creates for you. Gives you some context over here as well. I need to replace this with the current database. What is my database? I started it using Docker. And as I said, the default database is Postgres. The username is not John Doe, it is Postgres. The password, of course, is this thing that we sent it. And it's running on localhost on port 5432. So this is my final database URL where I want to migrate, where I want my application to put data. That's the second change you have to make. Number one, start Docker locally. Number two, change it in the environment variables. Number three, npx prisma migrate to actually run SQL commands over there. You can make it more fancy, like give it a name. Npx unknown command migrated. Npx prisma migrate dev -- name, give it whatever name you want. What does this command do? Number one, this command creates a folder for you. As you can see, it says applying migration something. If you look at prisma /migration/ a new folder that was created /migration.sql, it wrote some SQL for you. It wrote create table request, has an ID, has an answer, so on and so forth. And it ran this against my database. It actually sent this create table query to my database so that my database has migrated. My database now has a requests table. What do we have to do next? npm run or whatever, tsc-p and node dist/index.js. If I now try to run it, bin.js, and go to Postman and send a request, you will see it returns me. Answer is 3. ID is 1. If I send it again, ID is 2. Seems like the database is doing its thing. It's auto incrementing the ID. What did I write in schema.prisma? I wrote ID by default will be auto increment, which means 1, 2, 3, 4, 5 like that. That is exactly what is happening here. If I send another request, ID 3, so on and so forth. And hence it seems like our database is up. You can do other things to confirm. You can actually open your database and see the data is there, but we can almost tell the data works. We have written a manual integration test. We did a lot of manual steps to test our functionality. Does it work? If I send it 10 and 0, does it return me back 10? Acha, it does. So seems like my application is up. How can we do all of these steps in an automated fashion? By all of these steps, I mean, number one, starting a database somehow. I had to right now manually run this command and then migrate my database. How can I somehow automate this in a script so that it automatically starts? I run some automated tests. That is what we'll discuss in the next slide. bootstrapping the integration tests using vtest. This is slide number 5. Slide number 4 was just how you start the database and how do you confirm if the data is in there. You can run npx Prisma Studio to actually check the database if need be. If I run npx Prisma Studio, it will open this. If I go to requests, I see 4 entries have been put there, which means things are working, everything is good, database is fine, we're good to go. How do we automate this testing now? Let's automate it using vtest. Specifically, we'll write integration tests. Step number 1, bring the testing library locally. If you're using Jest, you would do npm install ts-jest. If you're using vtest, you would do npm install vtest. Let me bring this locally. While this happens, what is the next step? This is important. You could totally run a docker command. You could, I ran a docker command here, right? Which was docker. If you remember, this was the docker command I ran. I could totally put this in the final script that we are writing over here rather than doing docker compose up, rather than using docker compose. But you should use docker compose because if you're in a specific folder, if you're in this file, it has a docker compose file here. If you run docker compose up multiple times, it will know what all is already running, what all it needs to run. Basically, if by mistake, I have the docker run script at the top and by mistake I run this script twice, then it will try to start docker twice. Versus if you use docker compose, there are 2 benefits to using docker compose. Number 1 is you can describe everything here. Okay, I want a database that will use the image Postgres. It should always restart in case it goes down, restart it. These are the environment variables I want to send. This is the port mapping I want to send. If I have Kafka also, I will write below it, add another section called Kafka. Okay, please use the image called Kafka. These are the environment variables. This is the password of Kafka. These are the ports I want to run it on. If I want to add Redis, I will add the third thing here. So number 1, I have a single file in which I can write all of this code. That is the first benefit of using a docker compose file. If you don't understand docker compose, then you have to go back to the classes. But as the name suggests, compose lets you compose multiple containers. It lets you describe, here I want to start 3 services. Right now we've just written 1 DB service, but we can, add more things here like Kafka, Redis, whatever you want. So that is step 2 here. We'll see how this comes into picture later on. But let's create a top level docker compose.yaml file. I've created a top level docker-compose.yaml, which if you look at it, says I want this image to start. If you compare this and this, they are very similar. It says image to start is Postgres. This guy also said image to start is Postgres. It says the password is this thing. This guy also said send 1 environment variable. I actually don't need to send the other one. This is the extra thing. Even if you remove it, it's fine. This is the port mapping that's added here. This was the port mapping that is added here. Docker compose just lets you describe this in a single file so that if you ever want to start these services, all you have to do is let me stop my old container. If you started it with me, I would urge you to do the same. Stop your old container. Docker kill. And then all you have to do to start all of these services. Right now there is one, but if I add another service here called Kafka, here use the image Kafka and the port mapping for you is whatever. And let's say it expects an environment variable. And then I add a third one called Redis. Always forget what 273, I've totally forgot. Whatever the port mapping is. And if I run docker-compose up, it would start 3 of these services locally. Let's quickly do it for the database. If I run docker compose up, it says network created, container created. And if you look at the logs, it has a bunch of logs. Why was network created? By default, it creates a network if you're ever starting using docker compose. And all the images are connected via that network. It starts the container as well. If I open another terminal and run docker ps, you will see the container is running. But I did not have to write a complicated command. I only had to write docker compose up. That is the first thing that we did. Let me stop this. Now if I run docker ps, the image stops as well. Or you probably don't need to do the cleanup then. Never mind. Okay, that is done. Then create a script. This will come in later on. This will come in handy eventually, not for a while. But let's start to create some tests of ours. Let's create a file called reset-db.ts. As we'll be writing tests, we might have to reset the database, delete everything inside. And you can do that by basically calling prisma.request.delete many. This would delete your requests table, which is the only table we have right now. Harkirat, why did you put it inside a transaction? Don't worry about it. The reason I did was, if there are multiple tables, then you want all of them to be deleted or none of them to be deleted, which is why you put them in a transaction. But right now, since we have a single one, it doesn't matter. I could simply run prisma.request.delete many. What's the use case of this? A lot of times across test suites, if you have one test running checking the /sum request, another one checking the /multiply request, you don't want them to conflict. You don't want one to write something to the database and then other to use it or by mistake use it, and hence you just clean the database between test suites. This is just a utility function for that we have described. We won't need it for a long time, so don't worry about if you don't understand this. Even though this is straightforward, it returns a default function which just deletes everything in a database. Let me copy this and create a tests/helpers/reset-db.ts file, from where I'll be exporting this function by default. Let me make this much simpler. Export function clear DB. There you go. Where is clear? Oh, comma. There you go. Cool. That's the next step. Lastly, we create a script called run-integrations.sh. This is the most critical bit here to understand. If you understand this, you're good to go. This is the script that I was showing from the beginning, this long script. Let's just create the whole thing and try to, slowly build on top of it. Create a fresh folder called scripts, inside which let's create a script called run-integration.ts or .sh actually. It's a shell script. It's not a TypeScript file. It is something you run like this, /scripts. Oh, I created in the wrong place. Let me move this here. You run it like this, /script/run-integrations.sh. This is how we'll be running it. It's not a Node.js file. What all do we want to run here? Number one, Docker compose up in detached mode, so it starts Postgres. Number two, the most critical part is these 3 lines of code. Not critical, but like most difficult to understand part. This part ensures that the database is actually up. You can put a timeout, wait for 10 seconds. Put a simple script here that doesn't proceed for the next 20 seconds. And then you can run these 3 commands. That is fine as well. Or there is this very common shell file that you might see in various code bases from time to time, which is called wait for it. It has been written by some smart people. It's present over here. If you copy the script, basically it will copy it for you. If you want to find where it's present here. It's by someone called Vishnu Bob. It's a script that you can use to check are other services up. More specifically in our case, check is Postgres running on 5432, and it will stay hung until Postgres comes up. So let's bring this bash script locally by running this command. This will just copy it to our scripts folder. So if I run curl the link to this shell file and then output it in scripts/waitforit.sh, I'll just copy it locally. What is this file? This is a very long file. If you want to understand it, don't feel free to, but this is a very long shell script that's used very commonly across various code bases to do specifically this. What is it doing? You run this with an external service you want to poll. Is this service up? Is Postgres up? And it will only succeed to the next line or proceed to the next line if Postgres actually comes up. So what do? First we echo or we print on the screen, waiting for databases to be ready. Then we print on the screen, database is ready. In the middle, we're running this specific command to wait for the database to come up. Once the database is up is when we migrate the database, and run npm run test. Now what is this npm run test? We'll come to very soon. Like, what does this do? Currently package.json doesn't have a script called test, or it does nothing. We'll come to what this will do. But it finally, and takes down everything. You probably do need this actually. Okay, this is what our script does. Do we understand this script already? Or should we spend more time here? Should I just continue? Because if we continue, we'll run this and maybe we'll see more things. But do we understand high level? Achha, this is the script that's bringing up things before actually running the tests. We understand this. Great. 87%. Decentish. Let's run this. Before you run it, it'll give you permission errors. Okay, permission denied. So what you can do is chmod plus x ./scripts/star. It means make all of these shell files executable. By default, shell files are not executable to protect you because they can run very low on the machine. So you have to tell your machine explicitly, yeah, it's fine. I have written these. I trust them. And then if you try to run integrations.sh, notice what happens. Let's see. Most probably, the first line of code is running. It is trying to bring up the server in detached mode. Then we see a bunch of errors. First error it tells me is that Docker was not able to come up. Why? Because something is already running on 5432, which means I probably have it running from before. Let me kill this. And let me try that one more time. And now it says cannot reach database. Waiting. No such file or directory. Let me go to so the error it's saying, we should make this cleaner. So basically what it's saying is ./wait for sh doesn't exist because I'm running it from the root folder. So let me go to the scripts folder for now and run it from here. So that ./wait for it.sh does exist. If I run it from here, it says waiting for the database to be ready. It is currently waiting. It is currently on this step right here. And then it says database is ready, which means seems like things are fine. Finally, it says could not find a schema.prisma file that is required for your this thing because I'm running it from one folder inside. So I actually have to run it from the root folder. You can make this cleaner, but for now, let me just change ./wait for it.sh to be ./scripts/wait for it.sh. And then hopefully it should work. So what was the issue? The issue was whenever you're running npx prisma migrate dev, it tries to find a schema.prisma file there. It tries to find a Prisma folder. But since I was running it from here, it couldn't find the Prisma folder and hence it errored out. But now, if I ran it from the root folder, it works. Everything is fine. It was able to migrate the database as well, which means this ran as well. This failed because, well, npm run test does nothing right now. If you go to package.json, you will see npm run test does nothing. We haven't written any real tests either. Let's do that next. But before we do that, do we understand how to write an integration test or specifically start an integration test locally? Can we proceed to writing the actual test? Great. Let's write the actual test. It was 86%, which is decent. The actual test is very similar to the one we've written, only we don't need any mocking now. We want the actual database call to happen. So firstly, let's bring in supertest as a dependency. If you remember, this is the library we were using to test an Express application. And then let's create a source/tests/ some.test.ts file where we'll be writing our actual test. It can look very similar to what we wrote before. Let me just copy paste it. What does it say? Imports describe expect it from vtest, imports the app variable from /index.ts, imports request from here. This is the test that we've written. It is the exact same test as slide 1, only I have not written v.mock dot/db. I don't want to mock it anymore. Since I know a database will actually be running, I actually want Prisma to put data in the database. So let's see if this test works or not. How do you run npm run test? You go to package.json and you replace the test script with vtest. If you run vtest on your CLI, it actually starts to run all of your tests. And hence, now when the run integrations.sh would run this thing right here, this would go to package.json, figure out, acha, I need to run vtest. It will run vtest and the tests will begin to execute. Let's see if this works or not. What is the test that I've written again? Very simple test. Here, get the status and the body. Given I'm sending a post request to /sum with these inputs, and ensure the status is 200, ensure the body is answer 3, ID is expect.any number. I don't know if the ID will be 1, 2, could be anything. You can actually expect it to be 1 here. But just to make sure there's no flakiness in our tests, because the database can be finicky, sometimes they might auto increment or skip a few increments, and hence we say any number comes, it's fine. And answer should be 3 though, because I'm sending 1 and 2. If I now run ./scripts/run integrations.sh, it'll pretty much do the same thing, which is it'll start Docker. If you remember the script again, it'll start Postgres, wait for it to start, migrate the database, and then run npm run test, which now actually is running my tests. If you look at it, tests are actually running. It is actually telling me the first test succeeded. If I change the test to be something erroneous, if I expect 4 over here and rerun the whole thing, let's say, then the test would begin to fail. So it's very similar basically to writing unit tests, only you have to write an auxiliary script like this that starts all of your external services. Thankfully, it isn't too difficult. Once you have written this, now all you have to do is update docker compose.yaml to add more and more external services. If you have Kafka in the future, just add Kafka over here. Make sure whatever is in .env, make sure those credentials are right. If you have, Kafka credentials here, make sure you give the same credentials here in Docker Compose. Everything else should be straightforward, and you can just add more services here if need be. If you look at the tests now, they are failing because I changed the test body. If I revert it back, it will start to work as well. So yeah, that's a brief of how you create integration tests. In the next slide, I wanted to show how to connect it to your CI/CD pipeline. Oh, well, there's something else before that. Let's quickly cover this as well. This is fairly straightforward, then we'll take a break. Before each and before all functions, this isn't related to integration tests. This is generally true. Okay, if you want some piece of code to run before every test runs, before each test runs, you can create a top level block like this. Okay, before each of these tests run, first this should run. And what am I doing here? I'm calling the reset db function. If you remember, we wrote this, and what would it do? Reset db would delete my database completely. I've renamed it to clear db over here, but you get the idea. It would clear my database. Just if you want to, make sure the database is clean before any new entry is made, a new test is run. The thing to learn here is before each. If you want something to run before every test, you should do this. If you actually put this code block and run the tests, you will see 2 clearing db logs, because I have 2 tests over here. Before each of these tests, this specific code runs. Only when this code succeeds does the actual test run. Why have we done it? So that we're clearing the database. You don't need it here. We're not testing anything which needs, okay, this is the first entry in the database. But just good practice to not reset it here, but reset it once. The better thing to do is before all. Okay, before all of these tests run, just run this once. There might have been some other describe block that was testing something else that might have polluted the database. So let me just reset the database once, and then all of my tests can run. They don't have to reset it again and again. That is what before all lets you do. It means before all of these tests run, just once run this code base, which is why even though I have 2 tests here, the final log that you see here only has this log once, because I wrote before all. You can use the same in unit tests as well. This isn't an integration specific test specific thing. A lot of times you do this to clean something between tests. If you want to clean a mock, if you want to clean something else between two tests, you use the before each statement. If you want something to run before all the tests run, you use before all. Hoping that's straightforward. Let's take a 10-minute break, guys. We are at 8 p.m. here. Next up, we'll be understanding how to integrate these integration tests to a CI/CD pipeline. Then we'll understand end-to-end tests, and we'll write some basic code to test app.100xdevs.com, and I'll give some hints as to how can you introduce this to the repositories that we have, and then we'll go from there. Let's do a quick poll first, and then I'll open chat for the next 10 minutes. Let's take a break. How was the flow until now? Do we understand everything? Yes or no? Sort of. 84%. Let me open chat, and since we have 10 minutes, happy to answer any questions you guys might have. Oh wow, a lot of questions. Okay. Can't reach database while running the script. That means either you don't have Docker. Make sure, are you able to, if I had to debug this, how would I do it? It's saying it cannot connect to database. That means the very first command is not running, or it's not running correctly. So I would run this independently, just this. Okay, yeah, let me run this. Is it giving me any errors? It's not giving me any errors. Then I would check, is it running on the right port? Do I have the correct port mapping over here? So, try to debug it by running just the first thing. If it says it cannot connect to the database, that means the database isn't coming up for you locally. Check why is that. When will be the Kubernetes class? Most probably next week onwards we're starting Kubernetes. My doubt, suppose we are running the application, our Postgres is up on Docker, but when we have to run the tests, do we have to stop the Docker container or not? My doubt is, suppose we are running the application. If you are running the application and you're using Docker for that as well, then yes, you will have to stop it. Or what you can do is have a separate port in your Docker Compose, have a separate port for testing. The testing database, run it on 5433 and make sure your .env also has, or your .env.test has a 5433 over here, so that they don't conflict with each other. But yes, you will have to stop. If you're using the same port, you will have to stop the original one while running tests. Are we modifying the original database while doing testing features like created things and updating things? You are not modifying the database. You're not touching the production database at all. This is starting a fresh database locally. You're putting all the data over there. You are not touching any production test database. How are we pass chmod line in GitHub Actions? You don't need to, thankfully, but you can. You can just put chmod plus x. It might throw an error, but it most probably will work. Thankfully, you don't need it in the CI/CD pipeline. It just works without it as well. The SS, all the code that you put already has access to be executed. I'll answer this at the end. We stick to class-related questions. How do we test load on a database? Load testing a database is significantly different from what's being done here. For that, you would load test your backend server, send a lot of requests there, which would forward it to your database. You probably wouldn't directly bombard your database with a bunch of requests. Probably can do that, but I would assume you would. There are standard ways to test backends. You can run a few scripts that send a lot of requests there, and then if the number of requests is very high, the number of DB requests might be very high. And that's how you load test a database. How do you check API if they are working or not? What if we have a huge request for the body, and how the testing are done there? For example, e-commerce website, I have to check whether order placement post API order is being created in DB or not. How do you check if the order is being created in DB or not? You would have another endpoint called a get endpoint. So what you would do is, along with this post endpoint that we had to create a request, or in your case, an e-commerce order, you can have another endpoint to get a specific request given an ID. Okay, const id equal to rec.body or query.id. And here you could, from the database, find, okay, hey, is there something with this specific ID? Where? And then, return that over here, request.id. And, whatever. A would be request.a, so on and so forth. And when you're writing the test, so you have this get endpoint. When you're writing the test, you would here be like, Achha, I got the ID right. I know the ID is whatever. Const id equal to body.id. And then I would send another request here which would be a GET request. To slash request, and question mark ID equal to whatever the ID is, and then check, okay, am I getting some contents? Am I getting the same A that I sent over here? So you would do a post followed by a get and test if it actually reached the database. vtest VS Code extension is helpful. I will install that. Okay, answer that. After each example, how can you check if API will the API node? Oh, there's also after each. Is that what you're saying? Yeah, there's also after each to run a test, as the name suggests, or to run a specific thing after each test runs. My doubt is, suppose we are running an, okay, answer that. 6 more minutes, we have time. All right, let's do one more round, but seems like there aren't too many doubts. Any more questions, guys, or can we just proceed? How .env.test would be used in Prisma? Yes, that's a great question. I mean, I can think of a few ad hoc ways. In your script itself, when you have your script, you at the top do cp./.env.test to ./.env. So you override .env with .env.test. But I'm sure there's a way. I'm not sure, but there might be a way to specify the env file to pick the environment variables from. But if a lot of this was inspired from this. Prisma has a series on testing, basically. How can you test a bunch of things? So there, if you look at it, their integration tests are actually the whole pipeline is slightly more complicated than how we have written it. And here, they have written a script, which is, let's see, where is it? Create a script to spin up the test no, that's not it. Oh, there you go, set env.sh. So if you look at this set env.sh file, right, it tries to export all of your variables from your .env file. It just puts them in your path, puts them in your bash terminal. So if you use this specific script, basically, to set environment variables, you can just replace .env.test. That's probably a cleaner way to do it. Okay, you have a separate .env.test file, and you do it the way they have done. So they had a separate script, which I ignored just to keep things simple, that sets all the environment variables. So here you can replace .env with .env.test and keep everything else the same. That way it will pick the things from the right place. But you'll have to figure out an ad hoc way like this. There's no clear path or easy way. Maybe there is, I don't know, to just pass a separate file to Prisma while tests are running, and then separate one to Prisma when they're not running. Finally, I got a DevOps engineer role as a fresher. Thanks for Kira. Thank you, sir. That's great. You should ping Ruki or Aryan or Akash. Ping Akash. They're both here in Bangalore. Why do people say there is not much growth in testing engineering? Because it's probably easier to write. That's the only thing. Writing these tests is a very manual task, and it's so manual it can be very easily done by AI. Probably that's the reason. But yeah, that's a high level. I don't know. I don't think that's true. Will we do projects on distributed systems? If not, we can learn from. If we do the, what's that called? Zapier project, then there might be some distributed systems there, but like nothing too fancy. So you should probably do it. What's the best resource for doing distributed systems? I can come back on that. Just ping Akash. Akash, let me know. Write this down as a question, and I don't know if there's a resource out there to learn distributed systems. But yeah, I'll find something. I have a friend who's basically the person who took the quiz yesterday, who's too much into distributed systems. I can just ask him, or connect you to him, or just ping Shake Dev on Twitter. He's very active. All right. Quickly recapping, we understood a little bit about unit testing. We recapped what unit testing is. We understood what integration tests are. How are they different? Then we understood the prerequisites. Before you write integration tests, you need to start some services. So we understood it's not enough to just write integration tests. You have to first write a full script that starts services. Then we manually started the database. Then we wrote this fancy script that you saw, where we first bring up the server and then finally run the tests after migrating the database. And then lastly, we wrote the actual integration tests, which are very similar to the unit tests, only there is no mocking happening over here. We actually have a database, we're putting data in there. Lastly, we understood about before each and before all. There's also something called after all that lets you describe if something should run before each of the tests or before all of the tests or after each or after all. That's what we've discussed until now. Next up, we want to understand how can you integrate this to your CI/CD pipeline. So let's get right into it. We're almost at 8:10 already. So let's understand how can you integrate this to your CI/CD pipeline. This is very similar to how we have done it in the past. If you remember in the unit testing also, there was a CI/CD section where we understood how do you create a script that, how do you create a CI/CD pipeline that tests whether or not someone's code is breaking tests. Exactly the same thing here. One thing you have to do before that is add a .env.example. You don't commit your .env files to GitHub ever. So make sure you have a .env.example file right next to your .env file over here, the contents of which can be exactly the same as the .env file. And this is the one that you actually commit over to GitHub. The .env.example is what actually reaches GitHub. What should not reach GitHub is .env, because by mistake you sometimes put the real production database here. You might commit it by mistake. So usually this is never put on GitHub. Only .env.example is what's pushed to GitHub. That's the first thing you should do. And then you need to create the CI/CD workflow, which is again a YAML file, which we've discussed many times. What does this one have to do? This just needs to run that script, right? The script that I have been running /scripts/run integration.sh. We just need this to run on the GitHub box anytime a commit happens. So what is the CI/CD pipeline? It says anytime there is a push on the main branch or there is a pull request on the main branch, then run this test job, run the following jobs. There is just one right now if you look at it. The test job, which runs on Ubuntu, brings in the code, checks out the code by using the actions/checkout at the rate of v2 GitHub action, then sets up Docker and Docker Compose. These are like standard actions that you use if you want your Ubuntu box to have Docker installed in it. And we do want that because we want to start Postgres over there, like a Postgres database. Then we check, is Docker Compose actually there? You can skip this step. Most probably this step would fail if Docker Compose isn't installed. You don't really need this step. Then we copy over .env.example to .env, because this is where the Prisma will pick up the database URL. And since we have not committed this, we first copy this over to .env. So cp ./one integration test .env.example to ./one integration/env. And then lastly, we run the script that that was just running locally, cd1 integration test and npm run test : integration. So one extra thing I've added here is, I've updated package.json. If you look at the final repository here, if you look at the package.json here, I added another script here called test : integration, which runs ./scripts/run integrations.sh. And then the original script still remains, which runs npm run test. In the CI/CD pipeline, what do I run? I go to the one-integration test folder, because this is where I want npm run. I don't want to run from the root folder. The root folder has two folders. You get the idea, right? We have two different applications. So I first go into this, then I simply run npm run test : integration. What does npm run test : integration run? It runs ./scripts/run integrations.sh. I can also run ./run/scripts/run integrations.sh. That works as well. By the end of it, if you look at this repository, it has a single workflow, which is the same thing that we just saw. Checks out the code, which means copies the code over to the Ubuntu box where it's running, gets Docker Compose, ensures Docker Compose actually exists, copies over .env.example to .env by running this command, and then lastly runs the integration script, which is go to the folder and then run npm run test : integration. What does this run? This runs ./script/run integrations.sh, where we've written all of that code. Is this working correctly? Yes. If you look at it, the latest commit that I did over here, if I click on details, it ran all the steps, including where is that step? Oh yeah, run integration script, which actually, waiting for the database to be ready, actually migrating the database, and then, whatever, running vtest, and then both the tests actually passing. If I create a pull request here where I have some RNS code, let me quickly create one where I don't put anything RNS. If I commit a random change where I'm not changing anything, not breaking any tests, and create a pull request, you will notice while the pull request has been created, an action begins to run, and this should succeed because I'm not really making any hazardous change here that would break the tests. Let's wait for this to succeed. What is the benefit of this? As external contributors come, you can simply come here and see whether or not tests are succeeding. If they are not, you can just let them know. Please fix it. The manual effort of a developer or the maintainer goes a little down if you have, integration pipelines like these. What are the common pipelines? Linting pe you put. If the lint is broken, if they have not put spaces in the right place, then a test should fail or an action should fail. Tests are breaking, action should fail. If the tests decrease coverage, a lot of times you then also break one of the actions. You create an action that checks has the coverage increased or decreased after this code base, and if it has decreased or if it has decreased by more than 0.5%, then you break that specific action and don't let the user merge. Basically, these are the common scripts or actions that you add. As you can see, this succeeded, but if I make a very random change, for example, if I go to one integration test source and index.ts and change something completely random, make this a minus b, and try to create a pull request, the tests will begin to fail, and I can look at them either on the pull request or on the commit, but you get the idea. Let's quickly look at this, and then let's proceed on to end-to-end testing. So wait for this to succeed. If you click on details, you can see all of the steps running one by one. It's taking a long time because it has to install Docker on that machine. I'm assuming that's a step that takes a long time. Maybe not happen fairly quickly. Running integration script. This should probably fail now. Oh, something is up here. I think the pipeline is incorrect. Something is broken. It still works, thankfully, but wait for it. Seems like it's not found. That we should fix that. But thankfully it still works. And the test fails because I changed the logic to be something wrong. There is a bug here, as you can see. Wait for it.sh is not found. It doesn't matter because by the time the control reaches here, the database is already up, thankfully, so I did not have to wait for it. But this is something we should fix. But thankfully it did not affect us right now. That is a brief of integration tests. Next up, let's move to end-to-end tests really quickly. Let me do a quick poll. Do you already know end-to-end tests? Cypress, have you created one of these, started a browser, things like these? How many of you already know this? Yes or no? Okay, that's mostly a no. 30% yes, even lesser, 25. All right. End-to-end tests are a slightly more ingenious way to do testing. They say, you are testing small services, backend only. You have a full stack application. You have an application that looks like this, app.100xdev.com. A browser should come up. Browser should log in. Browser should check, does this person have access to ad hoc classes? Browser should check, inside when they click on this button, do they have two things? Browser should check if a video is playing and the user clicked on the pause button, did the thing actually pause? Browser should check if, you should actually open a browser and automate testing over there. That is what end-to-end tests mean. Until now, we have tested our front end and we have not tested our front end and back end together. We have almost assumed that back end is the place where you write tests. End-to-end tests let you spin up a browser. Actually a browser. Yes, actually a browser. A browser will come up and it will start to click buttons over there, put ID password, click on submit, open a page, click on a button over there. You write real tests that end-to-end test everything. They test not just the backend or a part of a backend. They don't mock anything. They start all the services, be it database, backend, frontend, and they actually open the frontend and click buttons. It's actually a slightly unoptimal way to test, right? It's a very performance heavy way to test. Starting a browser is very heavy. if you have 1,000 tests and you're starting browsers for everything, it will take a long time. But why is it good? Because it's end-to-end test. Literally covers everything, how your user tests the whole thing. So it catches a lot of errors you might not be able to catch otherwise. A good reference video is here. So Cypress is one framework that lets you do it. Thankfully, it's very easy to write. You write code like this. If you look at the code, what does it say? The code says, visit this website, get a button over here that says login, and click on that button, and then get two input boxes, put some email and password over there, and then get the button that says sign in, and then click on that button, and then ensure that the logout button is visible. After the user has logged in, they should see a logout button. That is how you write tests. If they don't see a logout button, if it doesn't appear, the tests will begin to fail, and hence you would know your sign-in logic is broken somewhere. Might have been broken on the front end, might have been broken on the back end. If you write a test like this and actually run it, you will literally see a browser come up. You will see this page open. You will see it click on login. You will see it put credentials, click on the sign-in button, and since the logout is visible, the test succeeded. If logout wasn't visible, the test would have failed. So that's what integration tests are. They're like pretty fancy to work with, but honestly, realistically, no one writes them too much unless you have a very weird use case. If you have a multiplayer full stack application kind of a thing or game, for example, we did this a lot at Gather. Gather had a lot of integration tests because I can't give a good. As people come close by, a few tests need to happen basically. If two people come in proximity, then you should start to hear the other person. Things like these can only be tested inside a browser because only inside the browser can you actually hear the other person. So the tests over there were, as people come closer to each other, does the audio begin to come up? Does the video come up? What is the quality of the video? If there are two people, the quality of the video should be high. If there are 100 people in a grid, so they would start 100 browsers that would talk to each other, and then they would test. Basically, this is the only way to test video applications. There is no other way to test WebRTC applications because writing backend tests where you actually decode the video is really hard, and hence Cypress is or any of these frameworks. These are like three popular frameworks. Cypress and Playwright are actually the biggest ones. Nightwatch.js is just one that comes in GSOC every year, which also lets you do the same thing, write integration tests. We'll be using Cypress. They're all fairly interchangeable, very similar to Jest and VTest. Doesn't matter, use whichever one you want. How do you write Cypress tests? Let me give a brief. We'll be writing it for app.100xdevs.com. You saw the code. It's fairly simple. We'll write similar code. We'll want our agent to open app.100xdevs.com. Click on the login button over here. Ensure that the login page actually opened, which is this page right here. Put some credentials over here. Click on the login button, and then ensure the user was able to see courses written somewhere or view content written somewhere. That is what we're testing right now. If this test ever breaks, something is up with authentication. But we are testing it on app.100xdevs.com. Cypress lets you test any website. You can literally give it google.com and it will open a browser and start to hit google.com. When you are writing end-to-end tests, you should ideally start everything locally, and this should hit localhost :3000. The slide over here hits a production system. So this is not the ideal way to test. This is not the right way to test. A lot of times people do this as well. They have staging environments, staging.100xdevs.com, and there are tests running every day, which open a browser and test it. And if ever anything breaks, it creates an alert. But usually what do you want? You want to first start everything locally, very similar to how we started in integration tests. And then, your final thing should not visit app.100xdevs.com. It should visit localhost :3000 and test the whole thing. Let's try it quickly for app.100xdevs.com. Let's see it in action and go from there. Initialize an empty TypeScript project. Let me quickly do that. We had one integration test. Let me add another folder here called 2-E2E or end-to-end tests. Let me run the right set of commands there, which is npm init -5 followed by npx tsc --init. Initialize a tsconfig.json, change root dir. You don't need any of this for now because we won't be writing any code. We're not writing any code, right? We are testing the production website. So we don't need any of this. We won't be using root dir, out dir. But out dir dist. And then create a source folder, maybe create an index.ts file if need be, that's fine. But then install Cypress. npm install Cypress --save --dev. What does this do? Adds it to dev dependencies, because this is a dev dependency. You don't need, Cypress doesn't run on your EC2 machine. It runs before in GitHub Actions to ensure things are working. On your final EC2 machine, you never use this, which is why we push it to dev dependencies rather than pushing it to dependencies. Then you write your actual tests. Thankfully, it lets you bootstrap a lot of the files by running npx cypress open. So if you run npx cypress open, it'll create a bunch of configuration files for you. You can write them from scratch as well by hand, but this is just opens up a GUI that lets you select the same thing. So what is the command that I ran? npx cypress open. It gives you two options. Do you want to do end-to-end testing? Do you want to do component testing? We have not covered front-end testing until now. How do you test a component? That is what this guy lets you do. We will not cover this. I don't think anyone does this. I have not seen any company. I mean, companies do it, but probably last on the priority list if you want to write tests. You'll probably write unit tests, then integration tests, then if need be E2E tests. Rarely will you see people write component tests. They just work. But if you want to, this gives you the tools for it. We want to do E2E tests. It will create all of these configuration files for us. Click on continue. Select the browser you want to run the tests in. Chrome is fine for me. You might see other options. Feel free to select whatever you want. And once you do, it will create a bunch of files for you. And feel free to close this now. It will create a bunch of tests for you as well. If you go to your code base now, you will see a lot of things. You will see a Cypress folder. You will see a cypress.config.js. Inside the Cypress folder, you will see a folder called E2E, which stands for end-to-end, and a bunch of tests over there. They have a website called example.cypress.io/todo, which is a to-do website. So most of their tests are written on it. Okay, what happens when you click over here? Does the cross appear? What happens when you click over here? Let's write our own tests, even though these are a good comprehensive list of tests to go through and understand. So what happens when you click somewhere? Let's get rid of the second folder over here so that we don't have too many tests. Let's just have the first folder called getting started and replace this todo.cy.js with whatever app or I don't know, cms.cy.js. And here, let's start to write the code. Notice this also has a describe block. This also has a before each block. This also has a it block. So this is fairly common in all testing frameworks. Okay, give access to these things. Describe means the same thing here. You have a top level describe inside which you put a bunch of connected tests to test together. Let me get rid of all the tests but one. And let's see what this does. Right now this goes to this website, example.cypress.io/todo, and checks, are there two to-dos that exist? Does the first to-do have the text that says pay electricity bill? Does the second to-do have text that says walk the dog? If you remember, what did this have? I deleted it so it went away. Pay electricity bill, walk the dog. And those are the two things it tests basically. Does the website do what it's supposed to do? What do we want to test? We want to test what happens when you go to app.100xdev.com, login, so on and so forth. The code that I've written looks something like this. Okay, firstly, before each test, visit app.100xdev.com. Then, in the first test, we check, is it able to log in? Sci.contains checks, is there something that contains login? Is login written somewhere? Does that button exist? If you go to app.100xdev.com in incognito, you will see the landing page that you go to has a login button. I can also check, is there a join now button? Is there a brightness button? Is 100xdevs written over here? Is there a footer? So on and so forth. But I've just put a basic check. Okay, does the login button exist? And then I've said, click on it. What does sci.contains login.click does? It says, what is the first place where login is written? Click on that specific button. If I just write this much code, right? Let me comment everything else. If I just write this much code, you will see a browser come and click on the login button. It will happen very quickly because I'm not waiting after this. But let's try just that much. Let's go quickly run. What's the command? npx cypress run. You don't need to send in -- browser Chrome. It's fine if you do. The important flag to send in is -- headed. What does headed mean? If you know headless, then you probably know what headed means. Headless means if you want to start Chrome in the background, if you want to start a browser in the background, a lot of times you want to open the browser to do some things, but you don't need a GUI for it. That's what headless means. So what does headed mean? It means you want to actually start the browser because we want to see the actual browser and see how things are happening. But when you're running it in a CI/CD pipeline, you don't need the -- headed flag. You would just run it in the background. We are putting it so that we actually see the whole thing. If I run this, you will see a browser comes up. It opens app.1xdevs.com. The website Indeed opens, clicks on the login button. If you saw, for a minute second, it clicked for a login button. Let's add the rest of the things. What is the next thing we say? We say, check that sign into your account comes. It should exist in the next 10 seconds. When you click on the login button, you don't immediately go to the next side, especially if you're server-side rendering like we do in Next.js. And hence, it might take 2 seconds, might take 3 seconds. So we say, wait for up to 10 seconds. You should see something that says sign in to your account. If you go to app.1xdevs.com and click on the login button, you see a text that says sign in to your account. So we ensure we have reached the sign in page or not. That's what this line does. Then we get the email field. Thankfully, on app.1xdevs.com, if you go to the login page, there is an ID associated with both of them, like both the input fields. If I do an inspect element here, you will notice there is an ID equal to email on the email field, and similarly on the password field there is a ID equal to password right here. So I can just get the ID field by doing sci.get, not sci.contains. Sci.get, whenever you want to type something in, change the contents of something, you use sci.get. Hashtag email. What is hashtag, Kirat? Remember, done some CSS. Whenever you have an ID, you put a hashtag email. Whenever you do a document .query selector, if you do a hashtag some ID, then it means give me the first element with this specific ID. It's a selector basically to get a specific element with a certain ID. That's what hashtag means. What does dot mean if you've done some CSS? It means give me the first element with this specific class. Since we know that the first input field has an ID called email, you can do a sci.get hashtag email. Dot type, which means actually type the email, and then actually type the password. This is actually the password to my account, which I will change after the class, of course. But you will type my username and password, and then this part is a little weird. This part, unfortunately, I had to do because there is no ID associated with the login button. We should put that there. Or, there should be an easier way to identify the login button. Unfortunately, since this button is also login, it is very hard to figure out, which one to click. And hence I've written some very ad hoc logic right before the class. Get all the buttons. Get me the fourth button from the top. This is the first button, second button, third button, fourth button. This is also button. So like somewhere in this order I found fourth is the button that it finds for the login button. And I've written this ugly logic. Ideally, you should write, better logic that now, there should be a better way to identify the button, which you can simply do by putting an ID over here. It's like fairly common to do. You put specific labels on elements that you can use for testing. And lastly, I ensure that view content appears. What is view contents? If you log into the website and you actually have some course, then it says view content here. So I ensure that the final page has come or not. This is the final test that I've written. Let's see if it does what it's supposed to do. Browser does open. Website opens, clicks on the login button, puts email, puts password, clicks on login as well. And then it closed very quickly because it saw view contents, but it actually opened the final page as well. That is how you write a simple end-to-end test that tests the whole thing. What is the problem? It is running on app.1xdevs.com. What do we need to do? We need to create another script. Call it, mkdir scripts. And then, here inside run-e2e.sh, we need to create a script like this that, starts DB, then starts backend. In our case, it's a Next.js application. So, starts Next.js server. If you want to put it on CMS, if you want to put it on daily code, it should first start the database using again Docker, basically the same Docker Compose thing we did in the integration tests. Then it should start the Next.js server. Then the thing that you should test ideally should not be app.1xdevs.com. It should be localhost colon 3000, because you want to test the thing locally. Every developer, when they're making a change, wants to test, acha, is this working or not? And if it is working, push it to GitHub, so on and so forth. That's the only thing that needs to change here. I'll not write that, but you should write that. That is the next steps if you want to do something. There are 3 repositories. For 2 of them, it should be fairly simple, specifically CMS and Daily Code, because both of them are Next.js applications, have a single Next.js thing you need to start. But the third one, Chess, is a React plus Express application. So here you will have to start 2 services. You will, in your run e2e.sh, you will start the front end first, then you will start the back end, and start to test things. End-to-end tests make a lot of sense for an application like Chess. Why? Because Chess uses WebSockets. There's no easy way to test WebSockets. But if you use Cypress, you can start 2 browsers, put them in the same room, make one move over here, make other move over here, make sure the moves are actually happening. So it would be actually pretty cool to build an integration test for Chess that starts to. That's exactly what as I said, multiplayer games is where you see this fairly often. You write tests because you're then testing the final functionality, right? So finally the person has come to your website and playing a game. Is it happening or not? So over there it makes a lot more sense versus standard e-commerce website. Over there end-to-end tests don't make too much sense. Right? Most probably it will just work. If your backend tests are passing, your end-to-end tests will pass. That's enough context, and that's all I had for today as well. So let me open chat next, and if someone wants to jam right now and code this, happy to invite you on a Google Meet. If let's just do a bunch of questions, but we have some time. So if you want to, feel free to. There won't be too big of a bounties on this, but do it, shadow it, try this out on all the repositories that we have. All right, opening chat. Bhai, in Turbo Repo I've created Zod validation folder in packages, and I'm able to access it in the next app, but not in the Express app. Can you please show it quickly? I have spent the whole day. What error do you see? Create a Notion doc with the error, put it on this thing. So you have 2 apps. One is Express app. Do you have it in the package.json? It doesn't matter, but do you have in the other package.json? Oh, one minute. 2 things. Firstly, do you have something like this? Add repo / whatever Zod in your Express app. If you do have it, are you using TSC to compile it, or are you using ESBuild? If you remember, I said when you're using Express, use ESBuild. If you're using Express with monorepos, TSC gets really hard. It's a way to, someone suggested in the code only a way to make it work with TSC as well. But try ESBuild, go back to the classes where we did Express, and that should most probably fix. That's probably why it's working on Next and not on the other thing. Working on Next, not working on Express. Is Cypress under the hood sending an HTTP request? What is the shape of that request? It's an actual browser, sir. There is no request response. Like, there is a real request. We hit a production website, sir. When I run this, literally a production website is running, right? Oopsie daisy. It is hitting app.100xdev. Oopsie daisy. I think I changed that. It is actually hitting app.100xdev.com. So it's Cypress is a framework that literally opens a browser, actually visits the website inside a browser, and checks is the login button over here, clicks on it. Are there fields over here? Puts the thing here. Is there a login button? Clicks on it. So it's not faking any request. It's literally visiting a website in a browser. It's like a human testing your thing by clicking buttons everywhere. How can we use end-to-end tests in CI/CD? How do you think? Just add a script. What are we running right now? We are running npx cypress and browser. You would not do it headed. You probably don't want to start the Chrome browser actually. You'll run it in headless. You don't need to give this as well. Just create a test script in package.json. Test :e2e, which does this. Most probably 99% this will just work. This should just work. So one thing you have to, so CI/CD, when the CI/CD pipeline is running, it needs to have Chrome over there, right? When you run npm install Cypress, I think it brings Chrome automatically. I could be wrong on this. So you might have to run, in your CI/CD pipeline, add a step. That's the only, I'm just trying to think of why this might not work. In your CI/CD pipeline, where did it go? Sorry, 1 second. Through week 25. in your CI/CD pipeline, you might have to add one step that actually installs Chrome on the machine, because so like installs Chrome on adds Chrome, adds Firefox, whatever browser you want. You might have to do that. I think when you do npm install Cypress, it brings Chrome or some browser if it doesn't already exist. I could be wrong on this. So the only extra step you might have to add is adding a browser on the machine. Everything else just run npm run test in the or test colon e2e, and yeah, that's pretty much it. All right, doc. Can I use ngrok or like ngrok to host WebSocket server? That is a good question. Depends on, probably not. So it's a tunnel, right? It forwards requests from there to here. You'll have to check. You basically try to do it. It's possible, it doesn't happen, it's possible it happens. Generally don't use ngrok for anything. Just use it for testing. And whenever you're deploying in production, there are better ways to do tunneling if you really want to host it locally. But generally, why do you want to host it locally? Like, use some cloud provider to begin with, and if you have a specific use case, I don't want the application to run on my server only. There are better ways to tunnel traffic rather than, don't use ngrok. I mean, I think they started something that lets you now do this only, tunnel requests in production for a production system. So maybe try using that. I don't know if it supports WebSockets though, because depends on how they've written the tunnel logic. If it supports persistent protocols, it might not. It depends on them. Just try it out and see if it happens or not. Can we use, answer that, open source projects to contribute to? I will not give any specific names, but dub.sh is a great one. If you don't want Stack, try it out. Documents is a great one. Look at it, see if you're able to understand the code. Maybe contribute to a different one. But if you want to just understand, am I able to contribute? These two are good repositories. They're maintained fairly well. We need database credentials in .env.example to run GitHub workflow, not production database credentials. You need some test credentials here. For example, in our .env.example, if you remember, I had this URL. Postgres is the username, my super secret password is the password, localhost :5432 Postgres. My secret password, this thing is the same as the thing that we have in Docker Compose. So just have to make sure, whenever you're starting the database for testing, the passwords that you have here are the passwords here. That's it. All right. Time to look at docs. Not related to class. Let me just then do this one. Oh, PRs. Every issue has a lot of PRs already. Can I raise PRs on top of it? Oof. You can, but it will become a mess. It's hard to review one PR. Another PR on top of it might be hard. It's just easier for you to contribute to their fork. And if they merge it, it works out for you. Won't it be difficult for you to maintain? It is. So I'm going to offload a lot of this to, let's see, maybe Nimit or Sargam. What should I ideally do in this situation? Go ahead and contribute to the issue or leave it the issue. If someone has contributed to it, don't contribute to it. There's no point of having two PRs. Yeah, that's high level. All right. Play and autoplay next video. Ooh, like Netflix. Looks pretty good. Let me come back to this. Let me just answer one more set of questions. Then happy to come back to this. Held second player. Oh, this is good. Wanted this. Like, share via link. Why is this only 72 lines of code? That looks pretty good. And that easy to review and is a big feature. So nice. All right. In August, I finished 6-7 months as a full stack developer. Okay, that's a big one. Is this Sujit only? Let me quickly do one more round and then I'll look at this like a very big thing to review. One last round, guys. Anything? All right. ngrok allows WebSockets, yes, for testing. First run ngrok config edit, then add. Okay, so you have to change some configurations and it seems like it lets you do WebSockets. But yeah, I want to raise a PR in chest repo for implementing pub subs. I think someone has already done it. Should I send moves to database before publishing it? No. So go to the end of the video where I have to explain the architecture there. Should I send moves? What are the edge cases? So why do you want to use a pub sub there? You want to scale it. That's why you use it. Okay. There are two reasons why you want to use it. Okay, if you want to scale it, we've covered this in a few classes, like this similar architecture. Let me quickly explain this one more time, which is, okay, you have two servers, let's say, and your users are connected to different servers. These are your users. This is user 1, this is user 2, this is user 3, and you want to You don't want to have sticky connections. You want user 1 and user 2 are in separate rooms. Same rooms. This guy is also in room 1, this guy is also in room 1. Yet they are connected to separate WebSocket servers. The only way this can happen is if you have a pub sub behind the two servers, which relays events. So whenever the request comes here, it first needs to go to the pub sub, and that's what relates here. Okay, you had a good question then. Your question was, should I put in the database? Because so this is where timing would matter, right? If you did end up putting it in a database, so number one, you should wait for the database. That's the for sure. Unless you do something I explained in the end of the video, which is there is a third thing that's listing on this pub sub, a third service called archiver, which archives all of these messages. This gets a little fancy, but let's say you don't have this. Then you first have to store it in the database. Only if the database request succeeds should you forward it to the pub sub and go the other route. Yeah. My ESBuild show quickly. Oh, 1 second. Just do this. Run this command. Let me just post it. Rather than doing tsc-b. Oh, not posting the right thing. Everyone. Rather than doing tsc-b, just run this and then run node index.js and see if that fixes it. I make an SGTN use Cypress for ET test case automation for EMR. Nice. So it seems like it is the popular framework then. There's always debate between Playwright and Cypress, but yeah, good to know. Many made Web3 UPI. I saw this somewhere, I saw Twitter or something. How does this work? What does UPI even mean? Okay. I am intrigued. Okay. Oh, have you made this? Okay. Okay, so this is not real UPI. You just let people link their UPI to wallet addresses, and they can send each other money on UPI. You've created another naming service then, right? You created another naming service similar to Bonfida, where people, rather than having Harkirat.sol or Kirat.sol, they're able to get Harkirat at HDFC Bank. Cool. Pretty cool. Yes, that makes sense. What I thought was it's actually connected to UPI. Maybe it is. Let me know if it is, but I'm assuming it isn't. It's very hard to do without regulation. Will we need database credentials? Okay, answer that. Don't need production credentials. Need some test credentials in there in .env.example. Does browser do the same thing as Cypress? No. Browser stack is for human testing. Humans go to browser stack and start a machine and test it. Maybe they have some automated testing thingy as well, but they're offering something else. Okay, you can test your thing on a very old iPhone machine. They have bought a lot of old iPhones, and you can open their website and go to browserstack.com, get access to a very old iPhone and start things there. That's what they do. Oh, okay, I do have to change the password. I will forget. So let me just do it right now. Even though this is like a fairly known password, if I'm being honest. So I'll do it after the class. Okay, cool. I think that's all the questions. Let's quickly open this one. In August, I finished 6 to 7 months as an internship as a full stack developer, mainly using Next and Type. I was named Employee of the Month 4 times before I left due to shifting to Web3. Then worked into the startups and software and moved to a specific domain, backend developer, cloud developer, Kubernetes developer. Over the past year, I work as centralized cloud, Golang and Docker. During the same time, I have accomplished the following. Created numerous in-depth projects in Golang. Began Kubernetes database cluster APIs 8 months ago. Practiced extensively. Worked with a client from Berlin. Completed 2 freelance projects and earned about 80,000 rupees with some projects still in progress. Then I primarily developed some CRDs and controllers for creating machine images, AMIs, backend APIs for managing clusters, resources, implementing Argo CD, Teleport, and GitHub CRUD APIs. Also create my own SSH client. Okay. Everything above is in Golang. Super interesting to begin with. I'm curious as to what your question is. Also created a video encoding service, image processing and web server Create a full stack microservice architecture for lead code plus chess. Told you in some previous class if you remember. Golang, gRPC, Postgres. That's pretty cool. Gain experience in Golang, backend developer, knowledge of started blogging in 2023, got around 100k reads, which includes a series on HLD and other topics like Docker and Kubernetes. That's pretty cool. Solved 600 on lead code as well in my first and second year. Now the point, okay. Currently in my third year. I'm seeking full-time roles. I need advice on how to navigate this. I haven't been very active on social media, like on Twitter, so I haven't promoted myself much. My planning to posting self-promotion. And if you have the connections, you know someone, please let me know. I have a friend who works in Kubernetes, like Google's Kubernetes team. They're very heavy on lead code, but if you are open to working on site on Google, I can refer you to the Kubernetes team. They use Golang primarily, Kubernetes, core Kubernetes. Like you'll be building the Kubernetes, not using it, like building it. And it's your resume. Ping Akash, who's on the call. Send your resume. Just send your resume as long as you have, you're about to graduate or whatever, or you maybe already working either way. If Google, working at Kubernetes at Google sounds interesting, seems like it should be fairly easy hire. They unfortunately only hire based on DSA, so make sure you polish that up. That's one place I can definitely refer. Other than that, if you've done video encoding in Golang, try going through LiveKit code base. That's another thing you can do. That might happen. That might work actually. Try going through LiveKit ka code base. They raised recently 2 months ago, so they might be a good company to try out. And most of their code is in Golang. Seems like you have a lot of experience in Golang. You just have to understand the WebRTC protocol, SFUs, some standard jargon. Seems like you should be able to do it. These are the 2 companies I can, I would do. You don't need any self promotion here. Google is a referral. The other one is I think you mentioned it in your third year, so I don't know if Google happens, but try LiveKit as an intern or full time. I think seems pretty doable. All right, lot of context, pretty contextual question. Hope you're on the call and haven't left. Cool guys, think we can call it early. Oh, whoopsie daisy. Call it a little early today. Anything else I guess I can help you guys with before I call it? Quiz for us. There's already a video posted on YouTube. Look at it. Like live stream that I posted yesterday, not on YouTube, that you can look at it and target the quiz, try to do it yourself. Cypress can be used for brute force attacks on websites without rate limiting captchas. Yeah, not Cypress. Cypress can, but there are a lot of browser orchestration tools like that. That Selenium is one popular one that lets you do what you're trying to do. Yes, it will be able to get around captchas, but browsers are very expensive to bring up, so it's not as easy as sending 100,000 HTTP requests. You can do like this. Starting 100,000 browsers, your machine will die. Please put offline video remaining part of your Paytm project and WebRTC assignment. WebRTC assignment I will 100%. Or one of these. Basically, one of these should happen this week. One of these will happen this week. I'll try to do both of them. These are top of the stack. Alrighty. Testing is easy. This only, man. You write a lot of this. Try to write some of this. It is. Everything is easy. What's hard is like people are lazy. Don't like to write code. But in the end, yes. There are some problems that come that you write when you write tests. But in the end, it's writing this a lot of times. That's where you spend your time. Learning any technology is not too difficult. Off topic. How do you securely deploy a backend in the most secure way and prevention of any kind of attack? Depends. So what is your use case? Your use case might be private keys, crypto private keys. Then you don't deploy it anywhere. You have a machine in your house and you have 10 bodyguards around it with bullets or guns. That's the most secure use case. Then it's like, I have a simple full stack website, but I want to, of course, I want to make sure that people can't access my code and can't do standard vulnerabilities. So standard in case of you, like you're right about just deployment. So deployment, you have to make sure your ports are closed. If a bug happens in your application, most of the times there's some application level code. Someone was able to do an SQL injection. So usually it isn't a deployment where a bug exists that can lead to a security vulnerability. Of course, if you have a machine open, all the ports open, that's bad. Have a very restricted port set that's open to the internet. If you have a database, make sure your database is only accessible from your servers and not over the internet. These are like standard things you can do. But most of the time, the vulnerability, if it comes, it will come in your application logic. Somewhere, you have a folder exposed. Somewhere, you're allowing user to inject SQL, things like these. So deployment is nothing too fancy unless you're doing private key management. Literally, if this goes away, then we lose billions of dollars. Other than that, it's very straightforward. All right, guys. With that, we will call it. I will see you guys next week and maybe in a few offline videos. Have a good day. Oh, sorry, good night. Bye bye.